In the heart of the Gobi Desert, where temperatures swing from -40 to +40 degrees Celsius, China has completed one of the most ambitious engineering projects in modern history, a railway line stretching 2,700 kilometers, built on elevated tracks that seem to defy the very laws of nature. This isn't just a train line, it's a statement of what's possible when engineering meets determination. But how do you build a railway through one of the harshest environments on Earth? A place where sand dunes shift like ocean waves, where permafrost and extreme heat exist in the same location, and where the ground itself refuses to stay still? The answer lies in a series of engineering innovations so bold, they've rewritten the rules of desert construction. The Gobi Desert isn't just hot and sandy, it's a geological nightmare that has challenged human ambition for centuries. Beneath the surface lies permafrost, frozen ground that can melt and refreeze with devastating consequences for any structure built upon it. When permafrost thaws, it turns solid foundations into quicksand. Structures sink, twist, and collapse under their own weight. For a railway carrying trains at high speeds, loaded with passengers and cargo, this is absolutely catastrophic. Traditional railways built directly on the ground would have failed within months, their tracks warping into unusable tangles of steel. The solution? Elevate the entire railway above the unstable surface. By lifting the tracks above the desert floor, engineers created a crucial buffer zone that prevents the train's heat and constant vibration from destabilizing the permafrost layers below. But elevation alone wasn't enough to guarantee stability. The support structures needed to be anchored deep into stable ground, bypassing the unstable surface layers entirely and reaching down to bedrock that wouldn't shift regardless of temperature changes. This required drilling thousands of pylons across the entire route, some extending over 30 meters down through layers of sand, frozen soil, and fractured rock into the solid bedrock that lay beneath. Each pylon had to be precisely positioned with millimeter accuracy, accounting for temperature expansion that could cause materials to grow or shrink, wind load from desert storms, and potential seismic activity from earthquakes. A single miscalculation in any of these factors could cause catastrophic failure that would ripple along the entire line. Engineers used advanced drilling equipment specifically designed to handle the extreme conditions, with cooling systems to prevent overheating and reinforced bits that could cut through frozen ground. Each pylon was then filled with specialized concrete, mixed with additives that prevented cracking in extreme temperatures. The concrete itself had to be engineered to cure properly in conditions ranging from severe frost to blistering heat, maintaining its structural integrity across temperature ranges that would destroy conventional concrete. Then there's the sand, the Gobi's most relentless challenge. The Gobi isn't just a desert, it's a moving landscape in constant flux. Sand dunes migrate with the wind, traveling dozens of meters in a single season, burying infrastructure in days if left unprotected. Sandstorms with winds exceeding 100 kilometers per hour can erode metal surfaces, crack concrete structures, and derail trains by creating unstable conditions on the tracks. Engineers studied desert wind patterns for years, deploying weather stations across hundreds of kilometers and mapping out corridors where sand movement was relatively predictable. They built massive windbreak walls, stretching for kilometers, planted specialized vegetation that could survive with minimal water, and designed aerodynamic structures to deflect sand rather than attempt to resist it through brute force. The walls themselves were engineering marvels, positioned at calculated angles to redirect wind flow and minimize sand accumulation on the tracks. But the real innovation was in the track design itself, which had to solve problems that don't exist in conventional railway construction. Traditional railway tracks expand and contract with temperature changes, a natural property of metal that engineers must account for. In the Gobi, where daily temperature swings can exceed 50 degrees Celsius, this expansion becomes extreme and potentially destructive. Engineers developed specialized expansion joints that allow the tracks to flex without warping, bending, or creating dangerous gaps. They used materials that could withstand both scorching heat that could melt conventional steel and freezing cold that could make it brittle, all without degrading in strength or reliability. Every rail segment was tested extensively in simulated desert conditions before installation, subjected to rapid temperature cycling, sand abrasion, and vibration stress that mimicked years of operational use. Only segments that passed these rigorous tests were approved for use on the actual railway line. Construction itself was a logistical war against nature fought on multiple fronts simultaneously. Workers operated in carefully coordinated shifts, avoiding the midday heat when metal surfaces became literally too hot to touch with bare hands and could cause severe burns. Water, the most precious resource in the desert, had to be trucked in from hundreds of kilometers away, with massive tanker convoys running continuously to supply drinking water for workers and water needed for concrete mixing and dust suppression. Concrete had to be mixed and poured within tight time windows to prevent it from drying too fast under the intense sun or freezing overnight when temperatures plummeted. Machinery broke down constantly, clogged by fine sand that infiltrated every moving part and strained by temperature extremes that pushed equipment beyond its designed operational limits. Replacement parts had to be flown in or transported across vast distances, causing delays that threatened the entire construction timeline. Yet the project kept moving forward through sheer determination and meticulous planning. Thousands of workers, engineers, geologists, and logistics specialists worked in precise coordination, communicating across vast distances using satellite communication systems that were themselves challenged by sandstorms and extreme weather. Supply chains were stretched to their absolute limits, with materials transported across some of the most remote and inhospitable terrain on the planet. Specialized equipment had to be developed specifically for this project, including vehicles that could operate in extreme sand conditions and cranes that could function reliably despite massive daily temperature fluctuations. Every aspect of the construction required custom solutions that had never been attempted before at this scale. And then there was the environmental consideration, often overlooked in discussions of desert engineering. The Gobi may seem lifeless to casual observers, but it's actually home to rare species and fragile ecosystems that have adapted to survive in these extreme conditions over millions of years. Engineers designed the railway to minimize ecological disruption, creating wildlife corridors beneath the elevated sections and ensuring that the elevated structure didn't block natural migration routes used by desert species. Environmental impact assessments were conducted continuously throughout construction, with biologists monitoring animal populations and adjusting construction practices to protect vulnerable species and habitats. After years of intensive planning, engineering innovation, and grueling construction work, the railway was finally completed. Trains now glide across the desert at speeds that would have been considered completely unthinkable just decades ago, connecting previously isolated regions to major economic centers and transforming the lives of millions of people. The elevated design has proven remarkably resilient, withstanding violent sandstorms, extreme temperature fluctuations, and ground instability that would have destroyed conventional railway systems. This railway isn't just infrastructure or transportation. It's proof that with enough innovation, determination, and engineering expertise, even the most hostile environments on Earth can be conquered. And it raises a profound question. If we can build this in the Gobi Desert, what else is possible?